Okay, so ask questions. Once I finish, feel free to ask questions, and we'll try to go from there. Okay, so here's the first thing you might run into. Question like this: find the ratio in fraction form. You got to key into those words, right? You're looking for a ratio, and you're looking for it in fraction form. That's what you got to pay attention to. So I say here secant of A. It really helps if you not think in a question like this, if you don't think about the reciprocal relationship, but just think about what is the secant when you think about opposite, adjacent, and hypotenuse. That's the better way to think this through. So how do you do that? Secant is the reciprocal of the cosine. We all know the cosine is adjacent over hypotenuse. So what's the flip of that? Hypotenuse over adjacent. So I know I'm doing the hypotenuse over the adjacent. And that's what I got to find. So again, what do? You go to angle A. You say, okay, I need the adjacent. Oh, bummer. I don't know it. And I need the hypotenuse. I got the hypotenuse. And then you got to say to yourself, okay, how do I then get the adjacent value? And you should say, this is a right triangle. I'm going to use the Pythagorean theorem. Numbers of you are messing up on the Pythagorean theorem. You are putting the hypotenuse first and squaring it. But remember, when you solve for the other side, it's a negative sign, right? And again, you can do a squared plus b squared equals c squared and solve that equation. But again, when you're solving for the other side, it's the hypotenuse squared minus the side squared. If you're solving for the hypotenuse, then it's plus. All right, so this is a 3. So what do I get? 49 minus 9. So this is the square root of 40. I don't want to quit there, right? Because, and again, I want an exact answer in this. If I say ratio in fractional form, I want an exact answer. I don't want to use my calculator. I don't want a decimal round off. I want an exact answer. And so I looked at, and whenever I have a radical, I'm always thinking to simplify, right? So I got to look and say, can I simplify this? Oh, yeah. This is a 4 times 10, and we all know the square root of 4 is 2. So this is 2 times the square root of 10. All right, great. What's my hypotenuse? It's 7. What's my adjacent? 2 times the square root of 10. And I'm going to finish off saying I can't leave a radical in the denominator. Let me rationalize the denominator. And your final answer on this is 7 times the square root of 10 over a 2 times 10, right? Which is a 20. If this 7 and that 20 would reduce, I would reduce it. In this case, it doesn't. So that's the way you're going to work your way through the problem. Secant, reciprocal of the sine, so it's hypotenuse over adjacent. Oh, bummer. I need the adjacent because I'm dealing with angle A. And so I got to use Pythagorean theorem, simplify the radical, now do the hypotenuse over the adjacent. In this case, you have to rationalize the denominator. Any questions on one? Anybody? Okay, so I picked probably one of the harder ones of that to show you, but that concept you have to be able to do. Use your calculator. So again, you have to think through these things if you're going to be able to come up with the correct answer. Let me find my calculator. All right, where did my calculator go? I just had it earlier. There. Dun, dun, dun. Oh, I'm going to pause because, by the way, make sure you have your... Okay, so when you look at a problem like this, you have to think, I have to find the angle. That's what you have to think. You got to think, oh, I'm finding an angle. And so this is just to punch it into the calculator, right? And, well, I shouldn't say that because, again, remember, when you find the angle, measure of angle x is cosine of -1 of that value, right? You're hitting your -1 button. And this thing is 69.8 degrees. That's a punch into the calculator. So on B, same thought here. I got to find the angle. I don't have a cotangent to the -1 button. Therefore, I've got to use the tangent. So I have to say to myself, the tangent of L is 1 over the cotangent of L. And so what's going to happen is the cotangent of L is 7/5. What's 1 over it? Just flip it. So tangent L equals 5/7. So how do you finish this off? Measure of angle L equals tangent to the -1 of 5/7. Okay. Punch that in. Your calculator's going to tell you. Just do it real quick. 5/7 inverse tangent, and that's 35.5 degrees. You're finding the angle. Finding the angle. That's what you got to think, and remember, your -1 button allows you to find the angle. -1 button gives you the angle. Problem like C, you say, oh yeah, good, give me a bunch of these, because all I got to do is punch this into my calculator. 3 degrees and your sine button, or your sine button and 3 degrees. This thing is 0.0523. And remember, we go to 4 decimal places. Your calculator is giving you the ratio in decimal form. Ratio in decimal form. The second example, though, remember, we don't have a secant button on our calculator, so we have to relate that to its reciprocal function. And the secant of 49 is the same as 1 over the cosine of 49 degrees. So you got to do 1 divided by the cosine of 49. Again, this is a ratio. And this thing ends up 1.5243. 1.5243. Okay, so whenever you have secant, cosecant, or cotangent, you got to relate it to the reciprocal function. You got that in your notes. I would review that. You won't have a ton of problems like that, but you'll probably have at least one of each to do that. So again, remember, the sine, cosine, and tangent functions gives you the ratio in decimal form. The -1 buttons gives you the angle. All right. Next thing, you definitely got to be able to deal with right triangles. So in this situation, I say find angle R. So we've done a bunch of these by now. This is really the nuts and bolts of trig. These problems will probably be worth the most on the test. So you look at angle R, you say, how am I going to find it? Well, what did they give me? They gave me the adjacent, and they gave me the hypotenuse. Therefore, I'm going to use the cosine function to find angle R. So I make up the equation cosine R equals the adjacent 7 over the hypotenuse 13. And again, I'm back to the problem I just showed you a minute ago. So the measure of angle R is cosine to the -1 of 7/13. Punch that in your calculator and away you go. And I got 57.4 degrees. Hey, by the way, make sure your calculator is in degree mode and not radian mode, because that will really mess you up. Then problems like this, where I give you an angle, I give you a side, and I want you to find another side. Okay, you're not going to use the Pythagorean theorem because you don't know 2 sides and looking for the third. You're going to use a trig function. How do you do it? As always, start with the angle. I gave you the opposite. You have to find the hypotenuse. Therefore, you choose the sine. And so the sine of 27 degrees, that angle that I dealt with, equals the opposite 11 over the hypotenuse, which is n. And just remember, you got to switch these out. You got to get your variable at the top. Things on the bottom go to the top across the equal sign. Things on the top go to the bottom. So it's 11 divided by the sine of 27. And you should think, hey, does my answer make sense when you finish punching this thing out? Because if your side is like point something, you know you did something wrong. All right, I got 24.2. Sounds reasonable to me. It's the hypotenuse. It's got to be the longest side. 24.2 is a reasonable answer. Sounds good, right? Again, you're switching out your variables. Got to go to the top, and the sine 27 at the bottom. So it's 11 divided by the sine of 27. Any questions on those two? You got to be able to do that. You got to be able to do that. Any questions on those two? All right. reference angle. So I can give you the reference angle. I can ask you for a reference angle, and I can start it with degrees, or I can give it to you in radians. You should be thinking, okay, I'm going to draw a Cartesian plane. I'm going to put that angle in standard position. Again, some of you still don't understand. This is 90 degrees. This is 180. This is 270. And this is back around the 360. So as I start my journey around, I'm at 90. I'm at 180. I'm at 270. So therefore, I'm about right there at 275 degrees, right? Okay, that's 275. Remember, reference triangles always go to the x-axis. If I used up 275 degrees, how much is left for this angle right here? You can go either way, it doesn't matter. Well, I used 275 of the 360, so just take 360 in this case and subtract 275. And it depends on where that reference angle is, right? So what is that, 60, 70, 80, 85 degrees? Is the reference angle. And it just depends on where you end up. You know, if I give you something in quad 2, you know, maybe this is 140 degrees. Well, I've got to go, if I go all the way to 80, how much is left? 40 degrees. If I give you something in quad 3, I'm going past 180. How much past did I go? That would be the angle, and that's the way you do those. Any questions on reference angles? Definitely got to do that. You've had that on both quizzes, all 3 quizzes, I think. Well, maybe the last 2. And so make sure you can do reference angles. Change to radians. Hopefully that's an easy problem. Right? And hopefully your thought is, with radians, I got to have pi, so it's got to be multiplied by pi over 180. Something some of you guys did on the last quiz is you wanted to use your calculator and just give an answer without pi in it. Normally we want pi in our answer for radians, and therefore this thing usually we want in fraction form. So we want you to reduce this. So get rid of the zeros. And what, 16? 2 times 8 and 2 times 9. So what is this? 8 pi over 9 radians. But we want you to leave radians in fraction form. So don't punch that in your calculator. Reduce the fraction. Usually I'm not going to give you things that are a real pain to reduce. And again, the zeros go away real easy. Makes life easier on you. And of course, the other way then, from radians to degrees, hey, you know you got to get rid of pi. So pi's on the bottom and the 180 is on the top. On this one, you can just straight punch it out on your calculator. Just punch it out on your calculator. 5 times 180 divided by 19. Because we're in degrees. And that can't be right. 5 times 180 divided by 19. Much better. 47.4 degrees. 47.4 degrees. Can you figure out how many degrees in 1 radian? I mean, it's just, you're just punching in your calculator 180 divided by pi. If you can't do that, then just take the 1 radian and change it to degrees, right? Times 180 over pi. Right? And you'll figure out it's 57.296 degrees for the number of radians, or number of degrees in a radian. Okay, so how about a problem like this, where we give you a terminal point and we want you to find a trig function. And so we're looking for the ratio here. So when I say find cosecant q, I want the ratio. I'll probably give you a little bit more instruction on the test so you know exactly what you're looking for. But therefore I'm looking for the ratio. So let me make the reference triangle. So you have to understand that the -3 is the x coordinate, therefore this is a -3, and the -8 is the y coordinate, therefore that's -8. So when I go to set up the cosecant, First off, I think it's the reciprocal of the sine, And the sine is what over what? So this has to be hypotenuse over opposite. So my angle's right here. So opposite I got, -8, but hypotenuse I don't. I'm back to the Pythagorean theorem. Square root. I'm looking for the hypotenuse this time, right? Look, if it's a -3 and you're going to square it, negative and negative is a positive. So you don't even have to worry about the negatives. -8, negative times a negative is positive. So you don't have to worry about the negatives. So this is 9 and 64. So what is that? Square root of 73? Nice. We don't even have to worry about simplifying that. So hypotenuse over the opposite, that's the answer. That's what I want. The ratio, square root of 73. Oops, put the negative in the top. That's it. Okay, again, I chose one of the harder ones to do on that. But again, you're just going to make the triangle, figure out whatever ratio you're looking for, and away you go. What if I would have said find the cosecant? Watch this. And this was 0.3 and 0.8, and that was 1. Then I'm thinking unit circle. And I'm thinking this. The sine of theta in a unit circle is the y-coordinate. I'll do the other ones just to review. The cosine of theta is the x-coordinate. Why? All right, so let me go back. The sine is what? Opposite over hypotenuse. The opposite is the x-coordinate, and the hypotenuse is 1. That's why it's y. Cosine, adjacent over hypotenuse. The adjacent is the x-coordinate, and the hypotenuse is 1. That's why it's x. And if we wanted the tangent, it would be y over x, opposite over adjacent. And I know that the cosecant is 1 over the sine. So this is 1 over y. So what would be the cosecant? In this case, 1 over negative 0.8. In this case, I already have a decimal. I'm going to leave it in decimal form. And I'm just going to take my calculator and do 1 divided by negative 0.8 and get the value. All right, because again, I know my relationships. 30, 60, 90, 45, 45, 90 triangle. I will give you the patterns like I have been giving you on the quiz. So I think the pattern for this thing looks like something like this. The 60 is there. The 30 is there. And let's see, I think this is x, 2x, and x times the square root of 3. I think is the way they set it up. That's not drawn the prettiest, but that'll work. All right, it's fine. Really should have made it taller. Okay, so you have to understand how to relate things. So if I say find n, I'm looking for the hypotenuse, and in this case, the hypotenuse corresponds to 2x. This is as hard as I can give it, because where the square root of 3 is, instead I have a 6. Some of you already know how to do this in your head right away. That's fine. Most of you don't, so most of you are going to use a proportion. And what I'm looking for over what it goes to in the other triangle, and just make the x a 1. 2 times 1 is 2. N over 2 equals 6. Back what I know over what it corresponds to on the pattern, square root of 3. Move the 2. Rationalize the denominator. This thing's not going to reduce, but if it would, if it could, I would. Actually, it's going to, isn't it? So we get a 3 on the bottom, the 3 and the 6 will reduce. And this thing just ends up being 4 times the square root of 3. Okay, so proportion. That's as hard as I can make the problem. The other way is quite easy. Let me just real quick do one the different way. You know, what if I would have gave this to you as 4? Then the problem's really easy, because the hypotenuse is twice, and this side is that value times the square root of 3. It'd be really, really easy. What if instead I gave you the hypotenuse? Oh, here, I'll make it hard. 7. This side is always half the hypotenuse, so 7 halves. And this side is always that 7 halves times the square root of 3. So the only hard time is when the side that's the square root of 3 is some other value. Then if you use a proportion, you can figure it out. All right, for time's sake, I think I'm going to skip number 10. But it's the same idea. This is as hard as I could give you the problem, because the pattern for 45, right, same thing as 45 would be what, 1, 1, square root of 2. And I think the pattern on the ACT or SAT is S, and I don't even know if it's 1S or S, whatever it is, but same thing, 1, 1, square root of 2. Again, make a proportion and solve. All right, we've been through that, so review. So I wanted to get this last one. Okay, so here's a full-blown graph. Y equals negative 3/2 sine 2 times the quantity theta minus 45 plus 1. So you gotta think through. First off, I need to know my amplitude. My amplitude is 3/2, right? Remember, the negative tells you how to start the wave. It doesn't. The amplitude is absolute value. Then I got to go to my period. There are 2 waves in every normal period. So again, this thing's in degrees, so 360 divided by 2 is 180 degrees. That's my period. Shift. This thing is shifted right 45 degrees. And vertical shift, this thing is shifted up 1. So I got to start somewhere. So I'm just going to put my vertical axis there. And I got to go, because this thing is shifted right 45, I'm just going to go in 45. Whoops, let me go. I'm just going to go in 45 degree increments. 45, 90, be 135, so 180, 270, 360, 460, let's see, let me make sure I'm doing this right. Yeah, 450. Okay. So, again, how do you start? At the starting point. Where does this wave start? Right 45. So I just like to put a vertical line for my start. All right, this is the start. How far do I have to go? I have to go from here 180 degrees. All right, so to make life, you know, you can count. If I'm at 45 and I go 180, I have to end up at what? 225, which is right here. That's one wave. If they ask me to graph this thing all the way through 360 or whatever, then I got to keep going. So I'm going to go one more wave. So again, now I'm going to start here, and I'm going to go another 180, which is right here. Okay, so I'm going to do the wave within that. All right, where's my rest? Up 1. All right, I need a vertical scale. Oh, let's go. Gonna have to go by ones because I got to go 1.5 high, don't I? So let's go 1, 2, 3, -1. Okay, where do I start? Up 1, right there. My rest. How high up do I go from that? I go 1.5 up from that. I'm just putting dotted lines just to help me easily graph this. I have to go 1.5 down from here. So that gets me to there. 1.5 down from my rest. Okay, got my max and my min. I'm just about ready to graph it, but I'm going to say to myself, self, do I remember the pattern for the sine? I'm going to say, yes, I do. All right. My sine pattern, this is the max, this is the min, this is 180, this 360, although the numbers don't really matter. And therefore I know that the sine starts at 0, and I'm going to start at 0 right here. And before I go any further, I got to deal with one other issue, and that's that this thing is reflected. All right. So it's easy to reflect, just do the complete opposite. So at the first quarter mark of my pattern, I'm at a max. Now I'm going to be at a min. So notice I have 4 marks between everything. So I have to be down at a min, right? I'm right here. At the midway, I'm back at zeroed. For this wave, zeroed is at the rest. At the 3rd quarter mark, where I should have been a min, I am now a max. And for this wave, it's right there. And I end up back at 0. And there's one wave of it, right? A period of 180, 45-degree shift to the right. And if I want to do another wave, I just repeat that. Min, 0, max, 0. And there's another wave. If I had to start back at 0, I just go back 1, which is there. And there I am. Make sure you also have in your brain the cosine pattern. Stop packing up. Not done. Stop being rude. All right. So to make sure that you also have in your mind the cosine pattern and that you can do that. Because again, if you know the key points, then you're graphing everything off of understanding the key points. If you try to do this with inputting values of the sine function and solving for the y value, you'll just get points all over the place. You won't know where you're at. Some of your calculators will graph this. All right, so if you know how to use your calculator, great. Hope you can interpret all that. Hope you can get your calculator in the right mode. But it's not too hard to understand the shifts and such. Any last questions on that one? So tomorrow's quiz, I'm gonna definitely include amplitudes, periods, horizontal shifts, vertical shifts, because that's mainly what we've done since the last quiz. And then everything else will be just kind of a one of this, one of that kind of thing to finish out the quiz tomorrow.